All right, hello class. Welcome to part 3 of the midterm review. So let's go ahead and continue with the rest of the problems. We started on 39 and we were able to calculate the centroid and we stopped short of finishing the problem. So this time we're going to calculate the coordinates of the circumcenter and the orthocenter. So let's go ahead and do the circumcenter. Remember that the mnemonic for the special centers for a triangle was my cousin always owes Anna banana ice cream, probably before Christmas. So, and here we're talking about the circumcenter, which is here C for circumcenter. So you're talking about perpendicular bisectors. Perpendicular bisectors, you may recall, cut each side in half and at a 90-degree angle. So we're going to have a perpendicular bisector cutting this in half. Right now this is at 8, and we've said that halfway between -4 and 8 was 2, and we found that by adding those two numbers up, dividing it by 2. And so this is going to be the halfway point that cuts this in half. And then if I extend this over, notice that it actually crosses this vertex here. So this is my right angle. So this is a perpendicular bisector for this triangle. Now let's do another one over on this side. So we need to figure out the halfway point of this side as well. We did this last time, but let's go ahead and calculate it again. So the coordinates here are 2, 8 at the top. Coordinates here are -4, 0. To find the halfway point, you add -4 and 2 and divide that by 2. And then you add the y-coordinates, divide that by 2. So we have here -1, and 8 divided by 2 is 4. So the halfway point was -1 and 4 right here. And so this is the point where we're going to cut it halfway. And we got to do it at a right angle. And now the only way to do this at a right angle is we need to find the slope of the original line, this side right here, and then find the perpendicular slope. And that's the way that we can tell what the halfway point is. Okay, so, or what the rather where it cuts it at a 90-degree angle. So let's go ahead and find the slope. So we need to figure out how much does it rise and then how much this is run. So it rises from 0 to 8, so that's a rise of 8. It goes from -4 to 2, so that's a run of 6. So the slope here is 8 over 6, which is the same thing as 4 over 3. Now, if I want to do the perpendicular slope to that, then the perpendicular slope is going to be the reciprocal, the opposite reciprocal, so it's going to be -3 over 4. So the slope of this purple line, I'm going to do it as purple, is -3 over 4. So that's my slope, and then I want to find the equation of that line. And the reason I'm doing that is because, well, I know the equation of this this line here is x equals 2, and I need to find the equation of the purple line so that I know where they intersect. So let's go ahead and do the equation of the purple line. We know that this coordinate is -1, 4, so let's do the slope-intercept form of that line. We know that m is -3/4 because we just found it. Now y is going to be 4, x is going to be -1. Let's go ahead and write this as a decimal. So this is going to be -3/4, which is -0.75. Now if I multiply these, then I get 4 equals 0.75 plus b. Then I'll subtract this on both sides. So I have b is 3.25. Then I can replace this b with 3.25, so I'll do that now. And that's my equation of that purple line. And now I know that where they cross is where x is equal to 2. So I'm going to plug in x equals 2 there, and that'll give me the y-coordinate where it crosses. So we have y equals -0.75 times 2 plus 3.25. This is going to be -1.5 plus 0 plus 3.25. And then subtracting those leaves me to 1.75. So that's my y value. So then my coordinates are 2, 1.75. Because remember we said that x was 2 in this example. So those are my coordinates. That's where in this case, the circumcenter is located. So we got 1.75 for my y coordinate. And they already said that it was 2. Oops, this is for this one. 1.75 for the circumcenter, and then 2 for the x coordinate. All right, now let's do the orthocenter. The orthocenter, remember, relates to the here AO, always O's. Orthocenter relates to the altitude of a triangle. So let's go ahead and do that over here. Same problem. The altitude is essentially going from the vertex to the opposite side at a right angle, just like this. So it turns out that this is also the same thing as the perpendicular bisector. So it just works out that way. Now we have another altitude that we can draw from here over to this other side. And remember, it has to meet at a right angle. So this is my right angle, approximately. Now, I don't know where that point is. I need to figure out where that point is, where it crosses this line. Or I don't really need to find that point as much as I need to find this point. So let's go ahead and find the slope of, let me color code this. This is the yellow line. And let's find the slope of the purple line. Now, to find the slope of the purple line, I need to find the slope of this line right here, this red line, and that's because I need to do the perpendicular slope. However, I already found the slope of that. It was 4/3, right? And so therefore, I don't have to repeat it again here. I know that the slope of this is 4/3, and then the slope of the purple line has to be negative 3/4 because it has to be perpendicular and it has to be flipped and switch signs. Okay, so now we know that the equation of that purple line is negative 3/4 x plus b. Now the difference between this one and the other purple line in this other example is that the coordinate here is different. The coordinate here is 8, 0. So we're going to use that here. So we got 8 is x. So let's change this to a decimal, negative 0.75. So we got 8 is x and 0 is y. So we got negative 0.75 times 8 for x. Now we got 0.75 times 8. It's going to be negative 6 and plus b. Then we'll add the 6 to both sides. We get b is equal to 6. So then I can go ahead and replace this b with a 6. All right, that's the equation of that purple line, that altitude. Now we're going to set that equal to x equals 2 because we want to figure out where they cross. So let's replace that with x equals 2. This is going to give us negative 1.5. We can just get rid of that 0 there. Plus 6, and then y is equal to 3.5. So that means where they cross is 2, 3.5, because x is 2 and y is 3.5. All right, let's go ahead and take a look at the coordinates here. All right, oops, it says 4.5. Let me double check that. Oh, that's bad mental math, yeah. So it's gonna be 4.5, not 3.5. All right, so the coordinates are 2 and 4.5. So 2 for x and 4.5 for y. All right, and that's how you calculate those special centers for a given triangle. Now let's move on to the next problem. Use the figure shown to find the angle 3 in this case. So angle 4 is 96 degrees. Angle 5 is 138. What is the measure of angle 3? Well, if we know that this is 96, then that means this red angle has to be 180 minus 96. And that's because this red and purple angle has to add up to 180 because it's a linear pair, it's supplementary. So that red one is 180 minus 96, which is 84 degrees. And this one also has to add up to 180 with 138. So we have 180 minus 138 is equal to 42 degrees. And then we can figure out what angle 3 is, because we know that the angles have to add up to 180 in a triangle. It's called the triangle angle sum theorem. So we have the measure of angle 3 plus 84 plus 42 is equal to 180. And then we can go ahead and solve for it. So measure of angle 3, add these together, you're going to get 126. Subtract 126 on both sides, and you get 54. So this angle is 54 degrees. All right, order the steps for constructing the copy of angle A. Drag the steps to place them in the correct order. So we'll go ahead and list the order of the steps here from 1 through the very end. Now I'm going to go ahead and first I'm going to cover the steps here before we list the steps in order. So if I wanted to copy this angle, this given angle, what I need to do is, first off, I need to draw this line right here. So I'm going to have to use a straight edge and mark some kind of point here, and then use a ruler or some kind of straight edge to draw that bottom side. So that's the first step. The next step is I'm going to use a protractor and draw an arc. I'm going to put the point of the protractor here, and then I'm going to use the other end of the compass, rather, not the protractor. I'm going to use a compass in order to draw an arc from this point onto this line. And I'm going to keep that same measurement when I do this. Okay, so I'm going to draw this line. I'm going to place the compass here, draw an arc along here, label this B and C. So that would be step 2. So this is step 1, and then this here would be step 2, and then step 3, I would use that same measurement to draw an arc along here. So this is step 3. Actually, I said it was step 2, but it should be step 3. Okay, and then we'll mark these whatever we want to mark them. Let's say X and Y. And then once I mark them, I'm going to need to draw this part here. So what I need to do is, for step 4, I'm going to take the compass and I'm going to measure between here and here, between B and C. And then once I know that, I'm going to take the compass, put it at Y, and then draw an arc over this way. And then I'm going to take I'm going to extend this out a little further just so that you can see. And then where these arcs cross, that's where I'm going to draw my other line. So I'm going to use a straight edge and connect those, and that will give me the copy of the angle. All right, then we can call this Z, for example. All right, so that's the overview of the steps. So let's go ahead and list them in order. So these are all the steps. So as I mentioned earlier, you're first going to mark a point, and then you're going to use a straight edge to draw the ray. In this case, I drew a line segment, but you can draw a ray there. The second step, you want to make sure that you place the compass at point A, and then draw an arc that intersects both, and then mark them B and C, which is what I did. All right, next you're going to want to do the, without changing the setting, place the compass at X, and then draw an arc intersecting the ray. So that's this part right here, place it here, and draw this arc. And then label that Y. All right, step 4, remember, is measuring this distance here. So place the compass at point C, and then open the compass to the distance between B and C. So we'll call that step 4. And then step 5, without changing the setting, place the compass at Y and draw an arc, and then use a straight edge. All right, and that's how you copy an arc, an angle. So Melanie wants to construct the perpendicular bisector of line segment AB using a compass and straight edge. Which diagram shows the steps of the construction? So if you want to do the perpendicular bisector of AB, you're going to have to take a compass and put the point of the compass at A, extend it so it's a little more than half of the line segment, and then you're going to draw an arc with the compass. So you're going to draw a nice size arc here, and you could draw an arc or a circle, doesn't really matter. Draw an arc here and continue the arc over here. So you might as well draw like a full-on circle if you like, or you could draw two separate arcs, doesn't really matter. Now, keeping the same setting, you want to repeat that for to go from B over, keeping the same width of the compass, and then you're going to draw another arc on the top and then another arc on the bottom. And you can draw a full-on circle if you want, or half circle, or you can just do little arcs there. Okay, so and then once you do that, then you're going to mark those points where they intersect and then use a straight line, a straight edge to draw that perpendicular bisector. And that's how you would do it. So let's see which example has the same idea. So it's not going to be A because you're drawing the arcs, but the arcs are not crossing here. The arcs are supposed to cross. B, this looks good. The arcs are crossing and they're about the halfway point, so that looks good so far. C, you're only drawing one arc and that doesn't help any. D, you're drawing arcs of different lengths. So in D, it looks like you changed the setting from here to here, from this width to a tiny width. So that's not very good. You want to keep the setting the same so that the circles are of the same size. All right, so the answer here is B. The steps to construct the interior point of angle CAB for the angle bisector are given. Which step is not valid? Okay, so if we want to do an angle bisector, here are the steps. You're going to have an angle. So let's say we have angle A. Now you're going to use a compass to put a point on A and then use the pencil end of the compass to construct an arc along this angle. And then you label those, for example, C and B. That's the first step. The next step, you want to take the compass and place it at point B and then the pencil end somewhere inside this angle. And then you're going to draw an arc. You're going to then, keeping the same setting, you're going to put the compass on C and then draw another arc into this angle as well. And notice that the arcs cross. Then you're going to mark the point where those two arcs cross and use a straight edge to connect A to that point where the arcs crossed, and that would be your bisector. All right, so part A, if with one point of the compass on A, draw an arc that intersects both sides at B and C. We mentioned that. That's one of the things that you do. Place the compass on B and draw an arc. We mentioned that. That's what you're going to do. Open the compass wider and place it on point C and draw an arc. We mentioned that. That's what you're going to... Well, it says you're going to open the compass wider. That's incorrect. You don't want to do that because you want to keep the setting the same. As I mentioned, you're going to keep the setting the same for B and C. Draw a ray through point A in the intersection. Yes, that's true. So which step is not valid? That's going to be C. All right, a student used a compass and a straight edge to bisect angle ABC in this figure. Which statement best describes point S? So since these guys are constructing, so the student that's constructing this is constructing the angle bisector. So like this. Now for this angle bisector, whenever you construct this bisector, remember that you put your compass here and then you put the compass here and then you draw the arc here, right? And then you do the same thing here. You keep the setting of the compass and you draw another arc. Okay, so as you're drawing these arcs here and here, you're keeping the setting of the compass the same so that the distance here is the same as the distance here, because you're doing a circle here and you're doing a circle here. And remember, the circle has a constant radius. So as you keep the setting the same, the circle radius is staying the same. So these distances are supposed to be identical. So PS is equal to QS. So the statement that best describes point S is that the distance from S to Q is the same as the distance from P to S. What is the y-intercept of the line perpendicular to the line y equals negative 5/2 x plus 4/5? That includes the point -3, -1. So now we're dealing with questions involving equations of lines. So if we want a line that is perpendicular, remember that you're looking for a line with a slope that is the opposite reciprocal of the original slope of the line. So the slope of this line is negative 5/2 x, because remember y equals mx plus b is the slope-intercept form. And so m, remember, is the slope. So in this case, we have negative 5/2 for the slope of the original line. If I want it to be perpendicular, I need to switch, I need to, flip the fraction. So I need to find what we call the reciprocal and then change the sign. So if one is negative, then the new slope is going to be positive. And so if I switch this, I get 2/5. Now the perpendicular slope, we can plug that into this equation. So we have y equals 2/5 x plus b. Now the point that they gave us here, -3, -1, is the x and y coordinates, which we can easily plug into this equation. So we have -1 equals 2/5 times -3 plus b. And then we can go ahead and solve for b here. So we have 2/5 times -3, put this over an invisible 1, and then multiply straight across. So we got -6/5. We can add this to both sides. We get b equals -1 plus 6/5. To add this together, remember we need to have two fractions, and we're going to use a common denominator. The common denominator is 5, so I'm going to multiply top and bottom by 5. So I get -5/5 plus 6/5. So -5 plus 6 is +1. So we have b is 1/5. So we can plug this back in for b here. So let's replace it. We get 1/5 for our equation. So y equals 2/5 x plus 1/5. Now they want the y-intercept. So the y-intercept of the equation is 1/5. Remember that in the slope-intercept form, the y-intercept is b and the slope is m. So they want the y-intercept, which in this case is 1/5. What is the equation of the line passing through the point 2, 3, which is my x coordinate, x and y coordinates, perpendicular to 2x plus 7. So we have 2 as my slope, and then over invisible 1. Now I'll flip it, do the reciprocal to get 1/2, change the sign from positive to negative, and that's my perpendicular slope. So we'll plug it into y equals mx plus b, plug in that slope there. And then we'll plug in our coordinates 2, 3. X is 2, y is 3. Now I'm going to put this over an invisible 1, multiply straight across, and that gives me -2/2. -2 divided by 2 is -1. And I can add 1 to both sides. And so I get b is 4. Then I can replace this with my equation for b. And we got our equation for the line. Kim is asked to write an equation of a line that passes through the point 1.2, -3.8, so x, y, and is parallel to the line 6x minus 219. So this is the slope is 6. Now if we want it to be parallel, remember that the slope of the parallel and the original line have to be the same. So the slope of the parallel line is going to be 6. This is going to be the same slope as this guy. So we have our equation y equals mx plus b. In this case, m is 6. Plug in x and y. So y is -3.8. X is 1.2. 6 times 1.2, so 7.2 plus b. Now we'll subtract 7.2 on both sides. We get b is negative, looks like negative 11. So we'll plug this in here, change that to a negative 11, and that's our equation, 6x minus 11. What is the equation of the line perpendicular to the line presented by this equation? So the slope is negative 1/3, and then we'll do the perpendicular. So we'll flip it and change it to positive. So it's going to be 3/1 or just 3. We got our x and a y. So we got y equals 3x plus b. Y is 10, x is 4. We get 10 equals 12 plus b. Subtract 12 on both sides. So b equals negative 2. Then we can replace this with negative 2. All right, given points 4, 5, negative 6, 10, and negative 2, 8, what is the value of the ratio ml to ln? So we have we have 3 points on a given line. So for example, let's see here, we have m is somewhere here. That's going to be n here. M, n, and negative 2, 8. And so these 3 points are on a line, and we want to figure out what is the ratio between those distances there. So we want the ratio from m to l and from l to n. Now, because this is a diagonal line, we need to do the distance in the x and the distance in the y. But you can just do one of those dimensions. You don't have to do both dimensions to be able to solve this. Okay, so you can actually focus on one of the dimensions at a time. So if I were to just look at the x dimension, and I can figure out the distance in the x. So let's go ahead, and we know that we have n, l, and then m, right? So we have n first, which is an x coordinate of negative 6. We have l, which is an x coordinate of negative 2, and then m, which is an x coordinate of 4. So we can do the distance between between negative 6 and negative 2. So how far apart are these two numbers on the number line? Well, they're 4 apart. So the distance is 4. How far apart are negative 2 and 4? Well, they're 6 apart on the number line, and you can easily find that by doing 4 minus negative 2, and that'll give you 6. Absolute value. Okay, so we got the distances here, so the ratio here from ml to ln, so we want to do m first, so color code this. So from ml to ln is going to be a 6:4 ratio. You can see that based off of the colors that we have here. All right, so, and then we can reduce this. Remember, this reduces, you can divide this top and bottom by 2, and you get a 3:2 ratio. Point R divides a line segment with endpoints 4, 5, and 10, 14 in the ratio, such that PR to RQ is 1:2. So the ratio of the distance from P to R, and then R to Q is a 1:2 ratio. What are the coordinates of point R? Okay, so if the ratio from P to R and R to Q is a 1:2 ratio, well, that means that so that means, and let me draw this a little bit more accurately here. So that means that the distance from P to R is smaller than the distance from R to Q. In fact, the distance from R to Q is twice as large as the distance from P to R. So that means the distance from P to R is 1/3 of the distance of the entire line segment. And this is the distance that we need for our calculation. What's the so from P to R is 1/3. Now, to find the coordinates of R, what we're going to have to do is we're going to have to find the distance from P to Q in the X direction and in the Y direction. So, okay, so we know the fraction is 1/3. What is the distance in the X direction? So what I'm going to do is I'm going to quickly draw the coordinates here, 4, 5, and 10, 14. Okay, so this is our line segment, and we know that R is somewhere here such that it's a 1:2 ratio. So we need to figure out where R is going to be. Now, in order to do this, I need to figure out how long it is in the X direction and how long it is in the Y direction. And so how much of a distance do we have in the X direction? Well, that's given by 10 minus 4. We can tell based off of the X coordinates. And how far is it in the Y direction? Well, it's 14 minus 5. And so the distance here is 6. So I'm going to say that that distance is 6. The distance here is 9. And so now I'm going to take 1/3 of this distance and 1/3 of this distance. And that's how I'm going to slice it. So I'm going to slice 1/3 here and I'm going to slice 1/3 there. And that will tell me where the line's going to be. So 1/3 of 6 is equal to 2, and that's because 6 times 1 is 6, 1 times 3 is 3, 6 divided by 3 is 2. Put this over 1, this is 9 over 3, which is 3. So that means I'm going to slice this like 3 units in, and then obviously the rest of the unit is going to be 6, because 6 plus 3 is 9. And then this is going to be 2 in. So I'm going to be moving 2 to the right and 3 up. So 2 units to the right, so 1, 2, and then 3 units up. So I'm here, so 1, 2, 3, that's going to be right around here. And that's where my R is going to be. So notice that's where I slice it here, that's where I slice it there, where they intersect. And this will lead me to have a 1:2 ratio. So the coordinates of R in this case, you can simply find them by adding 2 to the P coordinate, to the coordinates of P, and then adding 3 to the Y coordinate of P, which is going to be 6, 8. All right, so the coordinates of the endpoints of AB are given as such: -2, -5, 4, 3. What are the coordinates of point C that divides AB such that the ratio from A to C and C to B is 1:3? So this is the same type of problem. So I like to show the visual. So this is point A. And point B. This is my line segment. And we want to put a point C that divides this in a 1:3 ratio. And we're going from A to B here. All right, so let's go ahead and find the distance from A to B in the X direction. Well, that's the distance between -2 and 4. The distance between -2 and 4 is 6. The distance here in the Y direction from -5 to 3 is 8. And you can just subtract those coordinates and you'll see you'll get 8. All right. So now we're going to cut each of these by the fraction. Now, what's the fraction here? Well, if we're doing 1:3 ratio and This is A, this is B, and C is somewhere here. Well, from A to B, this is a 1:3 ratio, which means that the entire line segment is 4. It's worth 4 parts. And we're 1 part away for every 3 parts away from B from C. So it's from A to C is 1/4 of the line segment. Okay, so just add the 2 numbers and that's your denominator. And then the first number here is your numerator. So our fraction of partition is going to be 1/4. So put this over 1, multiply straight across here. 6 over 4 reduces to 3 over 2, which is the same thing as 1.5. And then this is 8 over 4, which is 2. So you're going to slice this up basically 2 units. And then you're going to slice this 1.5 units. So basically you're going to go to the right. This is positive, so you're going to go to the right 1.5 units. So 1.5, and then you're going to go up 2 units. So 1, 2, and then you're going to cut it, and that's where you cut it. So let me try that again. So we're at the -2, 1.5, and then go up 2 units, and it's going to be somewhere around here. It's going to be around here somewhere. So the coordinates of C are, let's go ahead and write the coordinates of C, are you start at A, and the coordinates of A we said are -2, -5. So you're gonna go from -2 in the x direction, and then you're gonna go 1.5 in the x direction to the right. And then from -5 in the y direction, you're going to go up 2 according to that calculation. So you're going to be at -0.5 and -3. So it's somewhere around there. And then that will be a 1:3 ratio. All right, what are the coordinates of the point 1/4 of the way from A to B? So you want 1/4 of the way, so they already give you the fraction. They don't give you a ratio this time, like a normal ratio. They just give you a fractional distance of the total. So again, we're going to do the same thing. I'm going to do this without the drawing now. Now that we've done the drawing, we should be able to do this without having to do the drawing. So we take the distance in the x direction. So how far is it from these two, from -6 to 10? Well, that distance is going to be the distance between those. You can find it by doing 10 minus -6, which is going to be 16. Now let's do the distance between the y's. So that's going to be 9 minus -3. And then, of course, you're going to do the absolute value of these numbers. And then that'll give you 12. Okay, so we got the distance. And remember, we're going to multiply, we're going to cut these distances by the fraction. So we're going to cut them by 1/4. So 1/4 of 16 is 4. 1/4 of 12 is 3. And so since this is the x direction, we're going 4 to the right. And this is the y direction, and it's positive, we're going to go 3 up. So this is telling us where we cut the distance. So how much are we going to move? So, and whenever I do these distances, notice that I do final minus initial. I always take the final coordinate. Actually, I don't need to do the absolute value because I'm doing the final and the initial. So every time I do these, I make sure that I do the final and initial coordinates. So if I get a negative number here, then I know that I'm going to go to the left, for instance. If I get a positive number, then I'm going to go to the right if I'm in the x direction. Okay, so just think of it as final coordinate minus the initial coordinate, and if it's positive, it'll tell you to go one way, negative will tell you to go the other way. So far, I haven't had any negatives. I've only had positive answers, but you could have negative here. All right, so now we're going from A to B. So our A coordinate is -6 for x, so we're going to go 4 to the right. If this were a -4, then I would just put minus here, and that would change my answer. But it's +4. And then the x here, or the y coordinate here is -3. We're going to do +3. And that will tell us where our c coordinate is. So -2, 0. All right, so use the diagram shown. Which side is congruent to GK? This one is not bad at all because you know that this is an angle, side, angle, angle, side, angle. And so you know that these two triangles are congruent. And clearly you could tell that this side right here is the side that is congruent to this side. So it's pretty easy to tell here. So GK is congruent to HL. Find the length of EF and the values of x given the length of AB is equal to 20. So we have AB is 20. Now if this is 20, then that means this has to be 20, right? So because they're both labeled with the same designation. So this is going to be 20. So 2x plus 8 has to be 20. And we could solve that. Divide by 2 on both sides, so x is 6. And then we can plug that in to get, well, we got x. So we got x is 6. And if we want to get EF, then we plug this into EF. So we got 3 times 6 minus 4, which is 14. All right, in the figure below, BC is congruent to DA. Angle 1 is congruent to angle 2, and line segment CF is congruent to line segment AF. What is the reason that completes the step 7 in the proof? Okay, so we're doing a proof here. So let's walk through the steps in this proof, and then we'll end up with our solution, which is number 7 in the last statement in the proof. So we know that BC is congruent to DA, so let's label that. This is congruent to DA. We know that angle 1 is congruent to angle 2, because that's given in the problem. Now, we also know that BEC, that angle there, is congruent to DEA. So this angle here. And that's because those are vertical angles. So they're congruent because of vertical angles. Vertical angles are always congruent. So vertical angle theorem. Now, because we have a side, we have an angle, angle, side, angle, angle, side. That means that those two triangles are congruent. So we know that triangle CBE is congruent to triangle ADE. Okay, so now that we know that those two triangles are congruent by AAS, that also means that CE is congruent to AE. And so we can go ahead and mark that. And that's just because if the triangles are congruent, that means all these sides have to be congruent to another side on the triangle. Okay, and that's due to CPCTC. Corresponding parts of congruent triangles are congruent. So CPCTC for short. All right, so now we know that those are congruent. That's going to help us later on. So I'm going to go ahead and erase this because we don't need this we don't need this part anymore. That just helped us to get to prove that this CE is congruent to EA. And now I'm going to use one tick mark so that I'm not confusing anything. All right, so those are congruent now. Now CF is congruent to AF because that's given in the problem. They told us that earlier. So CF is, so this whole side, CF is congruent to AF, that whole side. All right, and we also know that this side here is congruent to itself because these two triangles, this triangle and then this triangle, are sharing this side here. And so that side is obviously equal to itself. and that's known as the reflexive property. So this side is congruent to itself, so we can just mark that with a 3 tick marks. And now you see that this triangle has 3 sides that we know, and this triangle on the right has 3 sides that we know. And so those two triangles are congruent by they're congruent by SSS, because we know all 3 sides. We have side, 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 side. So SSS congruence is the final answer. Okay, triangle ACB is congruent to triangle ECD shown below. Which statement is not true? So we know that angle A is congruent to angle E based off of that statement. So this can't be correct because we're looking for the not true statement. We know that AC is congruent to EC. So that's not the right answer. We know that angle B is congruent to angle D, and that's not what this says. So that means this is the correct response. Complete the steps to the construction of an inscribed circle of a triangle. Okay, so remember that an inscribed circle for a triangle is a circle that is drawn inside the triangle. So the circle only touches the sides of the triangle and nothing else. So we have a circle that kind of looks like this, and it only touches the side of the triangle. So it touches the triangle 3 times, 1 on each side, but it's completely within the triangle itself. So that's an inscribed circle. And you may recall that we mentioned that an inscribed circle has to do with what we call an incenter, and that's the center of that inscribed circle. And an incenter has to do with, remember that mnemonic, my cousin always owes Anna banana ice cream, probably before Christmas. So incenter is related to the angle bisector. And the angle bisector is when you slice each of the angles in half, so like this. And where they cross is your incenter. And so it's important to know this because if you don't know what this comes from, you won't be able to construct the inscribed circle. So the first step in constructing the inscribed circle is to find the angle bisectors for each part, for at least 2 of the vertices of the triangle. So that's the first step. First step, find the incenter by constructing the angle bisectors of at least 2 angles. In this case, these angles here. Next thing what you want to do is, once you construct these 2 angle bisectors, you now know where your incenter is at. And then once you find that incenter, let's say the incenter is here, then what you need to do is you need to figure out the distance from the incenter to one of the sides of the triangle. And you need the shortest distance possible. So you want a distance that is you want a line segment that is perpendicular to that side, to either that side or this side or this side. And then find the distance, the length of that. Okay, so you need to construct a perpendicular, or you need to construct not a bisector, but a perpendicular line. So that's what you need to do, a perpendicular line segment. So first you're going to construct a perpendicular line segment from the incenter to one side of the triangle. Then you're going to place the compass on the incenter and measure from the center to the point where the perpendicular segment crosses the side of the triangle. So essentially what you're doing is you're taking the compass and you're measuring that distance with the compass. And that way you know what the radius is. And then once you know the radius, then you can take that compass measurement and draw a circle out of it. And that's how you construct the inscribed circle. So last step, draw the circle. Number 58, what is the radius of the circumscribed circle of triangle ABC? All right, using the mnemonic that we showed earlier, we can see that so this stands for centroid and median. And this stands for circumcenter. So this is the circumcenter, and this stands for perpendicular bisector. So circumscribed circle means we need to find the perpendicular bisector. All right, so let's go ahead and do that. And then once we do the perpendicular bisector, we're able to find the circumcenter, and therefore we can find the radius of the circle. All right, let's go ahead and find the perpendicular bisectors. So let's do the perpendicular bisector of this line first. So we need to find the halfway point of that line. This x-coordinate of this A is -5. The x-coordinate of this B is 3. So what's halfway between -5 and 3? Well, you have to add them together. So -5 plus 3 divided by 2. That'll give you -1. So the halfway point is -1 here. Okay, now we're going to cut this at a 90-degree angle, but that's pretty easy to do because it's straight up, and that will be a right angle. Okay, notice that this goes straight up to this vertex. This isn't always the case. This is only the case for equilateral and isosceles triangle. So therefore, these two sides probably are going to be congruent. So this is an isosceles triangle here. Now let's do the perpendicular bisector of one of the other sides. Clearly the equation of this line, if it's a vertical line, is going to be x equals, and it's going to be equal to -1 because that's where this vertical line crosses through. So x equals -1 is that equation. Now we need one more equation of another perpendicular bisector so that we know so that we can identify where they cross and solve it using algebra. All right, let's find the midpoint of this line segment. It looks to be around here, but let's double check that just to be on the safe side. So the coordinates of A here we said are -5 for x, but it's also equal to -4 in the y. The coordinates of C seem to be -1 for x and 6 for y. So let's average these x coordinates together. -1 plus -5 divided by 2. And average the y coordinates. 6 plus -4 divided by 2. And this will give me the midpoint or halfway point. This is going to be -3. This is going to be -2 divided by 2, which is 1. So indeed, this is the correct coordinate, -3, 1. So we got it right the first time just by eyeballing it. Now we're going to do a perpendicular bisector. So that means we're going to draw a line at a right angle to that. Now it's kind of hard to draw a right angle just eyeballing it if it's a diagonal line like this. So what we're going to do is we're going to find the slope of this red line, and then we'll use it to find the slope of the perpendicular line, okay? So the slope of this red line is how much does it rise, how much does it run? So it rises 1, 2, 3, 4, 5, and then it runs 1, 2. So rise 5, run 2. So the slope is 5 over 2. Remember to find the perpendicular slope, you flip the fraction, change the sign to negative, or the opposite sign. So the slope of this new line is going to be -2/5. So we're going to go down 2 over 5. 1, 2, 3, 4, 5. Down 2 over 5. 1, 2, 3, 4, 5. All right, and then that's going to be my line. Okay, so that's my perpendicular bisector, and we only really needed to do from here on, but that's fine. So where they cross is going to be my circumcenter. Now, it seems to cross just above that -1. So we're going to need to figure out the equation of this blue line so that we can pinpoint exactly where they cross. So let's go ahead and do that. Now we know the coordinates are the x coordinates and the y coordinate of that point. It's -3, 1. And we know the slope of that line. So we can find the equation using y equals mx plus b. So we got this slope here, -2/5 x plus b. Now we know that x is -3, y is +1. Let's change this to a decimal. Let's change that 2/5 to -0.4, okay? All right, so now we'll plug in y is equal to 1, x is equal to -3. So -0.4 times -3 is -1.2. Then we'll go ahead and add, let's see here. Yeah, then we'll go ahead and add 1.2 to both sides. We get 2.2 is equal to b. So we'll go ahead and replace this with 2.2. All right, so this is my equation. Now what we know, now we're going to figure out where it crosses, but we know that this is equal to x equals -1, so we can plug in -1 into this equation. So we get y equals -0.4 times 1 plus 2.2. Oops, I made a mistake with the b coordinate. So let's go back to this b coordinate. A negative times a negative is a positive. So let's change this. The b is going to be different. So negative times a negative is a positive. So we'll subtract 1.2 as opposed to adding it. And so 1 minus 0.2 is -0.2. There you go. That changes my b. So then we can change this to a minus 0.2. And then we can plug in 1. So this will change to a minus 0.2. So we got -0.4 minus 0.2 is -0.6. So it looks like the coordinate is around there. Okay, so this is around -1, -0.6. All right, so now that we got the coordinates, now we can figure out now that we know that this is the circumcenter, we can go ahead and I'm going to go ahead and eliminate these details just to kind of clean things up. And we can go ahead and calculate the radius. So if we want to calculate the radius, so the circumcenter, or the circumscribed circle, the way we come up with the circumscribed circle is the distance from there to each of the vertices of the triangle, there, and there, are the same. So each of these represents the radius. Each of these lines, or the length of these lines represents the radius. We'll call it r. And if you were to draw a circle using that radius, then you would get a circumscribed circle. And that's my circle. So let's find the radius of that circle. The radius of that circle is simply the distance from -0.6 to the distance of the c coordinate, which is 0.6. So what's the distance between -0.6 and 6? Well, that's easy. You just subtract them. 6 minus All right, I apologize. I in my response, I said that this coordinate, or I said that when I plugged in when I plugged in 1 into the equation, I got -0.6 for the coordinate for y. And that's, I plugged in 1, and I should have plugged in -1 for c. I put 0 here earlier. But yeah, the coordinate for c is here, it's going to be -1. The coordinate rather for this here is supposed to be, I was supposed to plug in -1. So if I plug in -1 here, then this turns into a positive 0.4, and then 0.4 minus 2 becomes 0.2. And that messed up my coordinate for the circumcenter, so I just wanted to address that in my circumcenter, the coordinates for that are not negative 0.6, which is what I got earlier. It's negative 1 and 0.2. So just wanted to address that, and that will change the radius for my circle. So the coordinates here are negative 1, 0.2. So we want the distance from 0.2 all the way over to positive 6. So 6 minus 0.2 is 5.8. So I know that my radius is equal to 5.8 for the circle. So we can say the radius equals 6 minus 0.2 or 5.8. All right, so we'll finish up the last couple of questions. Which of these needs to be completed first in order to construct a circle that circumscribes a triangle? So if we want to do something that circumscribes, remember, looking at this problem, what did we do? The first thing that we did was we had to make the perpendicular bisectors in order to do the circumcenter. So that's exactly what we're going to do. The perpendicular bisectors of any two sides of the triangle is the first thing that we do. Which statement is valid when a circumscribed circle of an obtuse triangle is constructed? So if we're constructing a circumscribed circle for an obtuse triangle, so let's draw an obtuse triangle. So it's a triangle with one obtuse angle. So something like this. That's an obtuse angle, and then we'll construct a triangle out of that. So for this obtuse triangle, let's draw a circumcenter for it. So we're going to do the perpendicular bisector, so halfway here, and then we'll cut that at a 90-degree angle. Halfway here, cut that at a 90-degree angle. Halfway here, cut that at a 90-degree angle. Here, here, and there. And notice that the circumcenter lies on the outside of the triangle. And if we were to draw the circumscribed circle, then it would actually touch the vertices. It's the distance from that point to the vertices is the same. Notice that those distances are the same. And then we can draw a circle that crosses the triangle at the corners, at the vertices. And that's my circumscribed circle in this example. So it looks very different for an obtuse triangle. So let's look at the choices to see which one is valid. The longest side of the triangle lies on the diameter of the circle. Now that's incorrect. So this is the longest side of that triangle, and that's actually not the diameter. It's actually a chord. It's one of the chords of the circle, not the diameter, not the main chord there. The circle is drawn inside the triangle, touching all three sides. So that is not true. The circle is not drawn inside the triangle, and the circle is actually drawn outside the triangle. Okay, so it's completely outside. The center of the circle is in the interior of the triangle. That's actually false. It's actually outside of the triangle in this example. The vertices of the triangle lie on the circle. That is true. The vertices themselves lie on the circle, but the rest of the triangle is inside the circle. All right, that's going to do it for the video, guys. I hope you found this useful. I know this is a long three-part series, but I hope you found some use out of the questions here. And as usual, I'll see you in the next one.